Hello everyone. So in the last class, we had done the degree of carbons, degree of hydrogen, degree of alkyl halide, basically haloalkanes, and we had understood what all different degrees can be there for the different compounds, depending upon you are wanting to find out the carbon's degree, hydrogen's degree, or halogen degree. So carbon can have four type of degrees: primary, secondary, tertiary, and quaternary, whereas your hydrogen can have only primary, secondary, and tertiary, and similarly your halogen can be primary, secondary, and tertiary. So these we had already discussed in the last class, and then now I'm doing the continuation of the same. So now we will talk about the degree of alcohol, which is very similar to degree of haloalkanes. So in the case of haloalkanes, what was the deciding factor of haloalkane's degree? So basically, on which carbon your halogen group is present would decide whether your halogen is primary, secondary, or tertiary. So exactly same way, on which particular carbon or which type of carbon your alcohol group is present, that will decide whether the alcohol is primary, secondary, or tertiary. Again, here there is no question of quaternary. What is the alcohol group? OH group is the alcohol group. So OH is the alcohol group what we are talking about, and this OH group on which carbon it is present will decide its degree. So I have written some examples over here. Look at the first example. Here you have CH3, CH2, CH2OS, OH. So basically I have to figure out the degree of the carbon first on which OH is attached. This carbon has one attachment to the carbon, so it has only one carbon as a neighbor, so it is primary degree, so automatically the OH or alcohol's degree has become primary, so we will call it as primary alcohol. Similarly, look at the second compound. So this is the center carbon on which OH is attached, and this center carbon is attached to three carbons, so this is the third tertiary degree, and we will call the alcohol as tertiary alcohol. Similarly, look at the third question. Here is the carbon which is attached to one carbon over here and another carbon over here. So basically direct neighbors are two, and hence the degree is secondary. So alcohol will become secondary alcohol. Now look at this compound. Here is the carbon on which OH is attached. So this carbon is attached to one carbon over here, one carbon over here, and one carbon over here. So three carbons it is attached to, and hence the degree is tertiary. So this is your tertiary alcohol. Now come to the fifth part. So in the fifth question, we have OH which is present on this CH, and the carbon is attached to two carbons. Hence the degree of this carbon is secondary, and hence the alcohol degree is also secondary alcohol. So I hope you would have understood how to find out the degree of the carbon. Once you know how to find out the degree of carbon, it is very easy to figure out the degree of haloalkane or alkyl halide or alcohol or any such thing. Okay, now let's talk about the next degree, that is degree of amines, and that is not same as haloalkanes or alcohols. That has slight change, so let's figure out what exactly it is. So degree of amines is figured out by a little different method. First of all, we have to understand what is amine. So the group which has nitrogen in it, basically if you talk about NH3, NH3 is called as ammonia. Now, if you make the change in this NH3 structure, basically hydrogen is replaced by any carbon chain, then the group will be called as amines. So basically, I have three hydrogens here right now, but if I replace one hydrogen with one carbon chain, the big long carbon chain or small carbon chain or whatsoever, we will write in the generic formula as R. R is the representation of the carbon chain. We also call it as alkyl group. So that's nothing else, but it represents that there is a carbon chain over here. So when hydrogen is replaced by the carbon chain, then the group is called as amine group. Amine or amino. Okay, now here where I have shown you that I have replaced one hydrogen with one R group, it is called as amine group, but that's not the only case. You can have multiple replacements also. Basically, there are three hydrogens, three replaceable hydrogens. If one hydrogen will replace with one R, then also it will call amine. It will be called as amine. If two hydrogens, let's say, are replaced by two carbon chains, maybe same, maybe different, then also it will be called as amine. And if I have all the three hydrogens replaced by three different carbon chains, then also it will be called as amine. The carbon chains can be of same type, can be of different type, can have same number of carbons, can be of different number of carbons. I have written here R and R dash. I have written here R, R dash, R triple dash to just represent that there are three different chains, but that's not necessary. You can have same type of carbon chains also at all the three attachments. So this group is called as amine. So basically N itself is called amine. Now, depending upon whether there are hydrogens or R groups, we will find out the degree of this amine. Now, this is the pure basis of figuring out the degree of amine. Now, if I say my nitrogen is directly connected to only one carbon chain, so I have this direct attachment with one carbon. So it's not basically one carbon. The carbon chain can be any length longer over here, but the other two attachments are still hydrogen. Then the direct neighbor as a carbon is only one, and other two direct neighbors are hydrogen. So in this case, when there is only one attachment with the carbon, we will call it as primary amine. And at that time, your group will be NH2. Basically, if you'll talk about the functional group will look like NH2. It's NH2 basically. And other part is the carbon chain. And this kind of compound will be called as primary amine. Now here, if I replace two hydrogens with two R groups, so R groups are nothing else but basically the carbon chain. So let's say if I have taken as a C, any length longer carbon chain it can be, and then hydrogen with nitrogen, and then other place I have played C. I'm not writing hydrogens. You can just assume that the hydrogens are already there. So basically, this nitrogen has two carbon chains as the neighbor and one hydrogen as a neighbor. So basically, direct attachment to carbons at two places and one direct attachment with hydrogen. So such kind of amine which is connected to two carbon chains or two direct neighbors are carbon, then the amine will be called as secondary amine. So in that case, your group will not remain NH2, but the group will become NH, or functional group will become NH. So this will be secondary amine. So you don't have to actually go and check how many carbons it is attached to. You can just simply look at the functional group. If it is NH2, then it is primary amine. If it is NH, then it is secondary amine. And if all the three places at all three bonds or all the three places have been replaced, or three hydrogens have been replaced by the carbon chain, and the direct attachment of nitrogen is with three carbon chains, then the compound will be called as tertiary amine. So here the functional group will be only N. It will not be NH2, it will not be NH, it will be N. So here, if there is only N, then it will be called as tertiary amine, or we can say it other way around, that if nitrogen is connected to three carbon chains, then it will be called as tertiary amine. Okay, so now let's look at this compound. I have here only one neighboring chain as a carbon chain, and rest of the two places we have hydrogen along with the nitrogen. Then this will be called as primary amine, or you can just directly look at NH2. If there is NH2, then it's primary amine. I have NH over here and two neighbors as the carbon chains. It is secondary amine. I have one nitrogen over here and three carbon chains, or you can say all the three places are with the carbon, are all the three R groups or all the three attachments at the carbon chains, then it will become tertiary amine. Now look at this compound, NH2, primary amine. There is NH, and it is attached to one carbon chain over here, another carbon chain over here. So two carbon chains it is connected to. It is secondary amine. Look at this, nitrogen here. I think I have not written hydrogen over here, but you have to use a bit of common sense. There is a chance they may not write hydrogen, and you have to use your common sense that they have just not written hydrogen over here. But here it was my mistake. So it was NH, and it is, if this is NH, it is attached to one carbon chain over here, one carbon chain over here. So two carbons it is attached to, or two carbon chains it is attached to, and hence it will be called as secondary amine. Now here if you look, nitrogen has formed three bonds with three carbons or carbon chains, though these are connected and forming the cyclic ring, but all the three bonds are linked to the carbons, and hence this compound will be called as tertiary amine. So that's how we figure out the degree of the compounds. Degree of at least these compounds. We will go further, we will understand carboxylic acid, aldehyde, We will talk about many other groups like ketone, all that. But there we do not talk about degrees. The degrees we generally talk about for these compounds like halogens, alcohols, and amines. And apart from that, the simple carbon chains, where we talk about the degree of carbon and we talk about the degree of hydrogen. So we should understand what exactly the degree means and how to find out the degree of respective carbon or hydrogen or alcohol or halogen or amine, whatever has been asked. So here we are done with the degrees. Now next we'll talk about degree of unsaturation. So as I mentioned, next topic is degree of unsaturation, which is also called as hydrogen deficiency index, or also called as double bond equivalence. So there are three names. One is degree of unsaturation, one is hydrogen deficiency index, and third is double bond equivalence. What exactly it is? Before we get into the understanding of degree of unsaturation, first of all, we should be clear about what exactly is unsaturation means. So unsaturation means presence of a pi bond, but where exactly? The pi bond, when it is present between carbon and carbon, then only it is called as an unsaturated compound. If this double bond or if this pi bond is present along with some other element, let's say oxygen or sulfur or phosphorus, phosphorus doesn't make double bonds, sorry, carbon with oxygen, carbon with sulfur, and so on, then the compound will not be called as unsaturated. So here, when we talk about unsaturation, we are basically dealing with the carbon-carbon pi bond. We are not dealing with carbon pi bond with any other element. So your compound will be called as unsaturated only and only if there is a pi bond between two carbons, not with any other element. Now, where do we need this degree of unsaturation? What exactly it means? Before we get into it, let's understand one more thing. Now, let's say if I have multiple different formulas, and if I have been given some molecular formula and somebody asks me to make the structures of it, what way we will be forming the structures. We have learned that in a compound, carbon can have carbon-carbon single bonds, double bonds, or triple bonds, or the combination of these, right? So let's figure out, if I have been given some set of molecular formulas, what all different structures I can get. I have C2H6. Okay, now if I have to make the structural formula, you try out on your own and tell me what exactly can be the structural formula for this. So the structural formula can be CH3 single bond CH3. It's not exactly structural formula, structural condensed formula it is. But yeah, so it is CH3 single bond CH3. So here what we have seen is that there is a single bond between carbon and carbon, and then hydrogen 3 at one end and a hydrogen 3 at the other carbon. Is there any other possibility over here? Can we have any different compound over here? I don't think so. We can't have. Now, if I remove one H2 from this molecule, C2H6. That means if I remove one H2 or 1 mole of H2, 1 mole of H2, then the molecule will become C2H4, isn't it? If I have C2H6, 1 mole of C2H6, if I remove 1 mole of H2 from it, what I'll get is C2H4. So what exactly has happened? The number of hydrogens are lesser, right? And the number of carbons have not changed. Number of carbons are still same. Now if I want to form the structural form of this, what will I do? First I will write carbon single bond carbon and will try to fulfill the valency of hydrogen. So here I have 4. So I can have 2 here and 2 here, but still it seems like the valency of carbon is not fulfilled, and hence I will make a pi bond over here. There is no other possibility. I know it directly and hence I have written it over here. You can try out multiple different ways by writing CH3 at one end and then CH at the another end. In that case, one carbon's valency will be complete and another carbon's valency will remain incomplete. So if I have to complete the valency of both the carbons and then divide the hydrogens also, in that case, the only formula which is possible is CH2 double bond CH2. So what does it shows? That as soon as I reduce the number of hydrogens, one pi bond got created between carbon and carbon. So basically, if hydrogen is lesser in the compound, the chance of being unsaturation is more. This is why it is called as hydrogen deficiency index. So for creation of unsaturation, we have to remove hydrogen out of it, or in whichever carbon the number of hydrogens will be lesser than alkanes, will have unsaturation in that molecule. Now again, let's look at another example. So if I have C3H8, again what we will try is we will form carbon single bond carbon single bond carbon, and now we'll try to divide the hydrogen. So this will have CH3, CH2 and CH3. So normal propane. Can we have any other structure out of it? Can we form any other kind of structure here apart from this? You can try out. There is no other structure possible. Okay. If I remove 1 mole of H2, the molecule which I'll get is C3H6. And let's see what can happen. I have just now mentioned loss of hydrogen or deficiency of hydrogen gives you unsaturation in the molecule. If you look at the formula very carefully, it is the formula of an alkene, CnH2n, and the molecule will become CH3, CH double bond CH2. And that's how the molecular formula will be correct. Apart from that, is there any other compound possible? Just think about it and try it out on your own. Yes, there is one more compound possible, and that is the cyclic compound. That is closed chain compound. We have studied about the cyclic compounds. I have told you earlier when we were talking about the classification that what exactly the cyclic compounds mean. So these are closed chain compounds. They are not open-ended. If I'll do that, the molecule will be, let's say I make the single bonds over here, and if I try to fulfill the valency over here, two hydrogens will be here, two hydrogens here, and two hydrogens over here. So CH2, CH2, CH2. So if I write it a little more neatly, it will become CH2, single bond CH2, single bond CH2. If I want to write the bond line structure, it will be directly this. So what can we see in this case is that there are two possibilities. One is either the cyclic ring, right, or the double bond. So what does it shows? It shows that wherever the double bond is possible, if you do not create the double bond, there is a possibility of formation of a ring. So either that compound can be a ring or it can be a unsaturated compound. So we can also say that wherever there is a hydrogen deficiency, that hydrogen deficiency will bring unsaturation in the molecule in the form of double bond, or you can also say the compound will become cyclic. So here what we generally say that rings and double bonds are equivalent to each other. Both contribute to the unsaturation. So unsaturation here is not specifically the pi bond. Basically, rings can exist only in those compounds which can be converted, or their other forms can be alkenes or alkynes, or the other forms which can be unsaturated. So basically we can say that the rings and the double bonds are equivalent. Wherever the rings are possible, double bonds are possible. Wherever the double bonds are possible, rings are also possible. So for the same molecule, for the same molecular formula, you can have ring also, and you can have a double bond, double bonded open-ended structure also. So we have understood what is unsaturation means, how unsaturation comes into the molecule. Wherever the deficiency of hydrogen is there, there will be an unsaturation in the form of a pi bond or in the form of ring. So how do we define the degree of unsaturation of a compound? It is basically how many number of moles of H2 you have to supply to any unsaturated compound or the ring structure so that that compound can become an open-ended alkane. So basically, how many hydrogens you have to add more in that molecule so that it can become an alkane basically tells you the degree of unsaturation, how much unsaturated that molecule is. The unsaturation is generally defined by how many hydrogens that molecule will accept and then become alkane. So how many hydrogens you have to basically put in to make it or to convert it into the normal open chain alkane. We are not talking about the closed chain alkane. Closed chain alkane is cyclic alkane, and cyclic alkane is equivalent to the double bonded structure. Okay, so let's see the definition. It is equal to the number of moles of hydrogen that must be supplied to convert an unsaturated compound or ring into an open chain saturated compound. So let me just explain you once more how what does it mean, and what we are trying to say. So let's say if I talk about the same molecule which we have discussed just now, so CH3 CH double bond CH2. If I have to, this is an alkene, if I have to convert it to the normal open chain compound or alkane, what will we do? If I add H2 over here, so H2, 1 mole of H2, one hydrogen will go and attach, basically pi bond will break, it will create two valencies over here, one for this carbon, one for this carbon, and one for this carbon. And now out of this hydrogen, the bond of hydrogen and hydrogen will also break. One hydrogen will go to one carbon, another hydrogen will go to another carbon. Let me just write it a little more neatly. It's like I had CH3, CH, double bond CH2, and I have reacted it with hydrogen. So I will write hydrogen as H, single bond H. Now, what has happened is the bond got split here, okay, and it created two new valencies, one here and one here on this carbon. One hydrogen went and attached on this carbon, another hydrogen went and attached on this carbon, and now the compound has become CH3 CH2 single bond CH3. Isn't it become an isn't it an alkane right now? It's a propane, right? So basically I had to supply only 1 mole of H2 to convert this into alkane. Exactly same way, let's say if I take CH2 CH2 CH2, the closed chain, okay, and now I wanted to make it an open chain. What will I have to do? I will have to break the bond between carbon and carbon. So I will split the bond between carbon and carbon, which will create one valency over here and one valency on this carbon. Now I have hydrogen. One hydrogen will go and attach over here, another hydrogen will go and attach over here, and basically the chain will become CH3 single bond CH2 single bond CH3. This has become propane. So basically, when I had taken alkene or I had taken the cyclic ring, I had just applied 1 mole of hydrogen, and then it had become what? Open chain alkane. So what is the degree of unsaturation? How many moles of H2 I had actually supplied to make it an alkane? Just 1 mole. So degree of unsaturation of this compound is 1. That's how we figure out the degree of unsaturation of any compound. So generally, what is the scenario what we see? If the degree of unsaturation of any compound is 1, that means that compound has either one pi bond, which we have seen just now, okay, or it is a ring. Either of them cannot be both in the same molecule. Either the compound is has double bond or the compound has ring. Now, if I say that the degree of unsaturation of a compound is 2, that means either it can have two pi bonds or two double bonds, or it can have one pi bond and one ring, or it can have two rings. So either of it we can have in the compound. Okay, so any combination can be there in the compound. It can be two pi bonds, it can be one pi bond, one ring, it can be two rings. Any combination we can have in the compound if the compound has degree of unsaturation as 2. So this is the way how we figure out the degree of unsaturation. Now I'll give you one example of one pi bond and one ring so that you will be able to relate it much better. Let's say if I have taken CH double bond, sorry, CH2 double bond CH, and then I have taken CH, CH2, CH2. So here I have a cyclic ring as well as the pi bond, both. Now I want to make it a normal alkane chain. So for converting it to normal alkane chain, what do I want? If this carbon will become alkane, it will become CH3. Correct? Just look at it very carefully. If this carbon will become alkane, it will become CH2. If this carbon will become alkane, what will it become? It will become CH2. And then one of the bond has to be broken. Now this is CH2, and this carbon, the end carbon, also has to be CH3. So this is the chain of an alkane, what we expect when this particular molecule which I have taken is going to get converted into alkane. So to convert this to this, what will I have to do? I will have to break this pi bond. Okay, when I will break this pi bond, I will add two hydrogens, basically 1 mole of H2, one hydrogen over here and one hydrogen over here. Similarly, if I have to convert this cyclic chain into the normal straight chain, normal alkane, then I will break one of the sigma bond over here between carbon-carbon, and then to fulfill the valencies what have got generated, I will add one more H2, out of which one hydrogen will go to this carbon, one hydrogen will go to this carbon, and that's how we will get this. So basically, two hydrogens, two H2s we will have to add in the compound CH2 double bond CH single bond CH, CH2 and CH2 to make it a normal alkane chain. So that's how we have got to understand that the degree of unsaturation of this compound is 2, because we need to give, or we need to add 2 moles of H2 to make it a normal alkane chain. So now let's understand how to calculate the degree of unsaturation for different compounds if they are given. Now there are two cases when we talk about the calculation of degree of unsaturation. One is if the structure is given. If the structure is given, then we can just simply count the number of pi bonds present over there and number of rings present over there. For each pi bond to break and make it an alkane, we require 1 mole of hydrogen. Similarly, for each ring to break, we require 1 mole of hydrogen. So basically, just count the number of rings and number of pi bond, and it will give you the degree of unsaturation. But just in case, if we have not been given with any structural formula, but we have been given with the molecular formula, in that case, we are not going to convert the molecular formula into structural first and then figure out what exactly is the degree of unsaturation. What we are going to do is we are going to just use a simple formula. So one way is calculate the number of pi bonds, the number of rings, and then just add it. Other way is if the molecular formula is given, then count the total number of carbons and then add 1 to it, minus count the total number of hydrogens, count the total number of halogens. What are halogens? Chlorine, bromine, iodine, fluorine. These are called as halogens. Add that, whatever the number of nitrogens are there, remove it, and then divide it by 2. Just use this formula. See how to derive this formula, how this formula came into the picture. We are least bothered about it right now. We don't care how this formula has come, because we don't have to deal with this formula very often. We generally look at the structure and we'll be able to figure out the degree of unsaturation. Even though you want to do it, you want to figure it out, that has to be the later choice. We are not going to deal with the formula derivation or anything right now. So what we have got, the total number of carbons we have to figure out, total number of hydrogens, halogens and nitrogens, and then place it in this formula, and you will get the respective degree of unsaturation. Mind it, just understand this, this X is a halogen which is monovalent. And if you talk about the nitrogen, this is trivalent. Right? So basically what we have taken is we have written number of carbons plus 1 and then minus and then bracket and then number of hydrogens plus how many monovalent you can say atoms are there, plus how many trivalent atoms are there, divided by 2. So instead of nitrogen you can have uh, any other element of the same family also. Okay, so instead of nitrogen you can have element of the same family also, like you can have phosphorus instead of nitrogen. So basically we are adding the monovalent atoms over here, the number of monovalent atoms minus the number of trivalent atoms. And then what about the divalent atoms? We are just going to simply ignore them. If we have any divalent atom present over there like oxygen, sulfur, we are not going to take its count in calculation of degree of unsaturation. This is something is very important and you have to remember this. Look at this. Again, I'm explaining you this. C is the number of carbon atoms. H is number of hydrogen atoms. X is number of halogen atoms. N is the number of nitrogen. Basically, X or the place of X represents the number of monovalent atoms. N or the place of N represents the number of trivalent atoms, and divalent atoms like oxygen, sulfur are neglected completely for the calculation of degree of unsaturation. Okay, we rarely use the formula, we majorly use the structures, and we directly use our brain to calculate the degree of unsaturation. So let's see some examples over here. So here I have written some forms over here. Just use the method what I have explained to you. All these places we have been given the structural formula. What you have to do is just count the number of pi bonds and the number of rings and calculate the degree of unsaturation. Do it on your own. Pause the video and then I will tell you the answers. You can match your answers with mine. Okay, so let's discuss the first question. If we see very carefully, there is only one pi bond, hence the degree of unsaturation is going to be 1. Look at the second compound, we have 3 pi bonds, the degree of unsaturation is going to be 3. Look at the third compound, we have 3 pi bonds and 1 ring, hence the degree of unsaturation is 4. Look at the fourth question. I have one pi bond here, one pi bond here, one ring, another ring. So basically 2 pi bonds, 2 rings till now, so total 4. And now look at this carbon and this carbon. So there are 2 pi bonds over here, basically in the form of triple bond. So 1 ring, 2 ring, 2 rings plus 1, 2, 3, 4, 4 pi bonds. So total 6 is the degree of unsaturation. Similarly, look at the question number 5. I have 2 rings over here. One ring is this one and another ring is this one. This compound is called as bicyclo compound. 2 cyclic chains have been fused together and the degree of unsaturation is 2. Look at the third question, sixth question. I have 2 pi bonds and 2 cyclic structures, hence the degree of unsaturation is 4. Now try out these questions also, and again pause the video, try them out on your own, and then I'll tell you the answers, match your answers with mine. Okay, so let's discuss again. So for this compound, let's see how many pi bonds are there. 2 here and 2 here. So total 8 pi bonds, and hence the degree of unsaturation is 8. Look at this compound. I have, let's count the total number of pi bonds first. 1, 2, 3, 4, and 5. 5 pi bonds. Okay. Now let's count the number of rings. 1, 2, 3, 4, 5. So 5 rings. So total 10. Look at the next compound. I will count the total number of pi bonds first. 1, 2, 3, 4, 5, 6, 7. So 7 pi bonds and 3 rings. So degree of unsaturation is 10. Look at the next compound. Again, 6 pi bonds and 2 cyclic chains. So degree of unsaturation is 8. Look at 11th one. We have 2 pi bonds and 2 rings. So the degree of unsaturation is 4. Look at the 12th compound, and 12th compound is a 3-dimensional structure which is cube, and this is also called as cubane in chemistry. So how many, there are no pi bonds basically. What we have here is the cyclic structures. So basically cyclic structures or the closed chains have been connected with each other. So how many cyclic structures do we have in cube? Let's see this. So if I talk about the cube, I have 6 cyclic structures basically. 1 here, 2, 3, 4, 5, and 6, the back one. I hope all of you know there are 6 faces. 1, then this is 2. I'm really bad at drawing. Let me just redraw it. So this is 1, this is 2, this is 3, this is 4, this front and back will be 5 and 6. So basically 6 rings seems to be there, and if 6 rings, we should have the degree of unsaturation is 6. But what exactly is the degree of unsaturation of this compound? It is 5. Why is it so? Special case, understand this, use a little common sense. As I have mentioned earlier, the degree of unsaturation means how many moles of hydrogen you need to supply to make the compound as the open chain saturated alkane. And when you will actually use this logic, and when you'll start supplying the H2 to this molecule and you'll start breaking the bond in such a way that it becomes a normal straight chain alkane, it will require only 5 moles of hydrogen, not more than that. Okay, even though it seems like there are 6 closed chains which have been connected with each other to form a cube. So you can try it out on your own. Try breaking the bond and start making it the normal carbon chain. First of all, write the carbons, carbons, carbons over here, and then start breaking the bond and start making it a long chain, then simple straight chain with all single bonds, and you will figure out that only 5 moles of H2 is required. This is not only in this case. You can see the next compound. Even in the next compound, it looks like 5 cyclic structures have been connected to each other to form this kind of structure, which is prism structure. In chemistry, we also call this compound as prismane. But if you'll actually supply hydrogens to it, because when you talk about the fundamental definition of degree of unsaturation, what exactly it is, it's not about how many cyclic structures or how many pi bonds are there. The actual definition or actual meaning of degree of unsaturation means how many moles of hydrogens are required to convert it into normal open chain alkane. This is the definition. Okay, the addition of pi bond and addition of cyclic structure is just a trick to calculate the degree of unsaturation, it may or may not work all the time. So in this case, if you'll try this out and you'll start breaking the bond and you'll try to make it an open chain structure, it will require only 4 moles of hydrogen. You can actually try it out at home when you're writing it in your notebook. Obviously, you have more time after the class, after this video. You can actually start breaking the bond and you will understand why the answer is 5 over here or answer is 4 in the case of prismate. And similarly, other compounds can also be there which are totally cyclic and the three-dimensional structures, and you will find that their degree of unsaturation is 1 less than the total number of cyclic rings have been fused together to make a three-dimensional structure. Now look at this compound. What I have done is I have taken this cubane, and in this cumane on each carbon which is there, every carbon, I have attached NO2 over here. So this is the structure what it will form. Every carbon, if you see, has an NO2 over here, and such kind of compound is called as octanitrocubane. What is this compound? This is the strongest known explosive. Strongest known explosive. Generally, explosives, when you'll talk about, are made up of nitrogen. Most of the explosives are made up of nitrogen, and this is the strongest explosive known so far. So there are many other, throughout when you will study the organic from beginning till the end, you will find out at many other places we'll be talking about the formation of different explosive from the generic compounds what we'll deal with, like glycerol, or you can say glycerine. Glycerine, if you do the nitration of glycerine, I hope all of you would have heard about glycerine. So glycerine we use in day-to-day life also. So glycerine, if you do nitration of it, nitration means when you treat it with HNO3 or HNO2 and you somehow add NO2 group in this glycerine or glycerol, the compound becomes a very strong explosive, and that is generally called as dynamite. So I hope you would have heard about dynamite also. We will talk about this reaction later on. This is just to tell you that where this cubane structure can be used. Okay, so this cubane, if you nitrate it, if you put an NO2, 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 or if you do the reaction in such a way with such a compound which can do nitration on each carbon, it will form octanitrocubane, which is the strongest explosive known so far. So this is about degree of unsaturation. Now we have understood how to calculate the degree of unsaturation if in different scenarios, if the structural formula is given, if the molecular formula is given. And I hope when I'll give you any compound in an exam, you will be able to find out the degree of unsaturation of that compound. Next, and the very important part of our chapter, that is nomenclature of the compounds, is what is going to start. Though we have understood the basic naming of alkenes and alkynes, when I started the basics of organic, I told you what is the suffix for alkanes, suffix for alkenes and alkynes, and what are the word roots, what exactly the word root means, and what are different word roots we deal with. So we start with the number of carbon 1 to carbon 10, and we had spoken about meth, eth, prop, but, pent, hex, sept, oct, non, dec, and so on. And we had spoken about the alkanes also. The simple alkanes are represented by the suffix "ane", alkenes represented by "ene", and alkynes are represented by "ine", and we have seen these names before. So what we are going to do today is, like, if you have the carbon chains which are a little complicated, have some branches attached to them, functional groups attached to them, or multiple double bonds are there, or multiple triple bonds are there, how will we name them? But we will do all of these cases one by one. We will start with alkanes first. And even before starting the naming of alkanes, the actual alkanes or complex alkanes, not only simple ones like methane, ethane, propane, butane, what different rules we have to follow, what is the basic structure of naming, that we have to understand. So when we talk about the naming of any type of compound in organic, it follows this basic rule. That is, the name will consist of a secondary prefix, a primary prefix, word root, primary suffix, and secondary suffix. Though all of these parts are not the mandatory parts, this will depend from compound to compound what all can be the part of name. For example, if I say primary suffix is something which is mandatory part of name of any compound you talk about, okay? Secondary suffix will depend upon whether we have functional group in our molecule or not, if there are different type of groups attached in the alkane chain or alkene chain or alkyne chain or not. Similarly, word root is the mandatory part of the name, though primary prefix and the secondary prefix, both of these prefixes are not the mandatory part. What exactly these secondary, primary prefixes, word root, primary suffix, and secondary suffixes means, let's understand. Though we have already spoken about the word root and we have already spoken about the suffix of alkane, alkene, and alkyne. So we will not repeat the word root listing. I hope you would be knowing all that what is the representation for one carbon, what is the representation of two carbons, three carbons, four carbons. If you don't know, go back to the old video, watch it again, where I had spoken about what are different word roots and how to name them, what the word root represent. Word root basically represents the number of carbons in the chain. Okay, and primary suffix, what exactly the primary suffix is, we will understand now. So secondary suffix, first of all, let's start with the secondary suffix. Secondary suffix is something which tells you about the senior most functional group. What exactly is the senior most functional group means? Subfunctional groups are made up of different other elements apart from carbon and hydrogen, or sometimes are made up of carbon, hydrogen plus some other element. If you have the normal carbon chain and there are multiple groups attached over there, like you have chlorine over there, you have NO2 over there, you have amines over there, you have alcohol over there, you have aldehyde over there, you have carboxylic acid over there. So there are multiple functional groups are there. Out of multiple functional groups, which one has the highest priority is called as senior most functional group. So that senior most functional group, or the one which has the highest priority, will be named in suffix. Apart from that, all other functional groups will be considered low priority functional groups and their names will be written in some other part of the name but not in the suffix. So secondary suffix represents the name of the senior most functional group. Senior most functional group, you can also say the highest priority functional group. Highest priority functional group. Okay. What is your primary suffix? Primary suffix tells you about the type of chain you have, what type of chain you have, or what kind of bonding you have. You have all saturated bonds or you have unsaturated bonds. If unsaturated bond is there, then how many unsaturated bonds are there? All that is defined by primary suffix. So primary suffix tells you about the saturation and unsaturation of the compound. For example, if I have only single bonds in the compound, the suffix will be "ane." If there is one double bond in the compound, the suffix will be "ene." If there is one triple bond in the compound, the suffix will be "ine." If there are two double bonds are there, so basically in the whole chain, twice the double bond is repeating, the suffix will be "diene." It's nothing different. You don't have to mug it up. Just use the little common sense. Di means two and ene means double bond. So basically two double bonds are there, so that will be represented by diene. If there are three double bonds in the whole carbon chain, so 3 will be represented by tri, and ene is ene. Okay, if you have 4 double bonds, it will be tetra. So di for 2, tri for 3, tetra for 4, and so on. Though we don't get so many, but yeah, just to tell you. So tetra means 4, and tetraene will be the name or will be the suffix. Okay. Similarly, if you have 3 triple bonds, you will have triene, 1 triple bond. Oh my God, what I have written over here? Sorry, it's not triene, it's triine. It's triine. If you have one triple bond, only ion. If you have two triple bonds, diene, and so on. If you have the combination of one double bond and one triple bond, let's say you have a compound where at one place there is a double bond, other place there is a triple bond. In that case, the suffix is going to be anion. N represents the double bond and ion represents the triple bond. So triple bond's name will come later, double bond names will come first, and we won't write ene. We don't write e and y together. Okay, so we will be writing anion. N will represent double bond and ion will represent triple bond. Now, word root we have already started. I have told you what is secondary suffix. I have already told you what is primary suffix. Now let's talk about the primary prefix, and primary prefix represents what type of chain you have, whether it's an open chain, it's a closed chain, it's a cyclic chain, how many cycles are there, how many rings are there. That is represented by the primary prefix, which may or may not be part of all the compounds. So let's say if your chain is a simple open chain structure, which may have a double bond, triple bond, or single bond, which will be represented in the suffix, but the chain is the open chain, then there is no prefix for it, no prefix at all. So let's say if I have taken the chain like this, CH3, CH2, CH2, CH3. Then in that case, the word root for this compound is bute. Why? There are 4 carbons. What is the suffix here? Ane. Simple. But is there any secondary suffix? No, we don't have. Why we don't have any functional group over here? Is there any primary prefix over here? No, because this is an open chain, normal straight chain structure, and we do not have any prefixes for the simple open chain structures. Okay. If I have a ring in my compound or my compound is a ring, in that case, the prefix is going to be cyclo. Okay. For example, if I draw CH2, 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 CH2. Now this compound is alkane actually. It has all single bonds in it made up of 4 carbons. So let's write the word root for it. The word root is going to be bute. And because it has all single bonds, it's ane. Is there going to be any secondary suffix? No, because we do not have any functional group. Do we have any primary prefix? Yes, we do. Why? Because it's a cyclic compound. And what prefix do we use? We will use cyclo to represent, or which will help us in distinguishing between a normal open chain butane and a closed chain butane. So this will be called as cyclobutane. Do we have any secondary prefix? No, we don't have, because we do not have functional group. Again, secondary prefix and secondary suffix both represents the functional groups, and unless these are there, we do not use them in our names. Okay. If I have 2 rings in my compound, we will use bicyclo as a term. If we have 3 rings, we will use tricyclo in our prefix. Though 3 rings we do not deal with, we will see 2 ring structures, and these will be represented by bicyclo. There are some other prefixes also, like spiro and all that, and we will come to that. Okay. For now, you just have to understand what exactly the primary prefix means. Primary prefix is nothing else, but it tells you what kind of structure your molecule has. Is it an open chain or it's a closed chain? If it's a closed chain, we have to use cyclo or bicyclo or tricyclo as the prefix to represent that these chains are cyclic. Now, what exactly is secondary prefix? If you remember, when I was telling you about the functional group, I told you if there are multiple functional groups present in your compound, in that case, out of all these multiple different functional groups, at least one will be the superior functional group or the most priority functional group. That functional group's name will be written in secondary suffix, and all other functional groups will be considered as weak functional groups or low priority functional groups, and those names or the names of those functional groups will be written in the secondary prefix. Secondary prefix not only represents the functional group, but there are other things also which it represents. Let's see what all secondary prefix can represent. It can represent all other functional groups which are low priority. So basically, we call them junior functional groups. Okay. Alkyl groups. Alkyl groups means branches. We have already discussed what is alkyl, what is alkenyl, what is alkynyl. So all this we have already discussed. And alkyl group is nothing else but out of alkane, when you remove one hydrogen, and let's say if I have CH4 and if I remove one hydrogen out of it, it becomes CH3 with a single bond, and this single bond, or with this attachment, it will be attached to the main carbon chain. It will be acting as a branch over there. So wherever this group is acting as a branch, this group will be called as alkyl group. Alkyl group is generally represented by R. Okay. So basically, when the branches are singly bonded, these are called as alkanes. If the branch has double bond, then it is called as alkenyl. If the branch has triple bond, then it is called as alkynyl. Okay. And how do we figure out whether it's a alkyl group or alkenyl group or alkynyl group? Alkyl group will be one hydrogen lesser than the normal alkane chain. Alkenyl group will have one hydrogen lesser than the alkene chain, because that one hydrogen would be actually creating a valency through which it will be attached to the main chain. So where it is acting as a branch. So that bond is basically attached to the main chain, where this alkenyl group or alkyl group is acting as a branch. Let me just give you an example. Let's see, H2 double bond CH, C, CH double bond CH2, CH double bond CH2, and hydrogen. Let's say this is my chain. Okay. Now here Let's say I have taken this as my main chain. So this part of my compound is acting as a branch. How, why, we will come to know. We will understand when I'll start teaching you the naming. So this is acting as a branch. Okay. Now in this branch, if you see, this branch is made up of two carbons. Okay, and there is a double bond over here. And if you actually see the molecular formula of this branch itself, it is going to be C2H3. And then there is one bond through which it is attached to this my main chain. Okay, so actually, if you talk about the alkene, which is made up of two carbons, the formula is going to be C2H4. Now, one hydrogen minus, and then it has become C2H3, and it is acting as a branch. And that one hydrogen has basically given you that one link through which it will attach to the main chain. So this is your alkenyl group, and similarly, you will have alkenyl groups. So names of alkyl, alkenyl, or alkynyl groups, basically the names of branches is something what we put in the secondary prefix. Apart from that, there are some functional groups which purposely do not have any suffix, even though they are alone in the whole compound, they still will have their names in prefix only. Basically, they don't have any name, they don't have their name in suffix, they don't have any term for suffix. Even though they are alone in the carbon chain, still they will be named in prefix only. Okay, and what are such compounds? Nitro. No matter you have only nitro in the compound or this nitro is along with other functional groups, this it will always be named in the prefix and the prefix will be nitro. Similarly, a group is nitroso. This is NO and this will be named always in prefix. Similarly, OR group, that is ether group. We call it ether. OR. Basically, the name is alkoxy. Actually, the name is not alkoxy. It's basically depends upon alk means the type of carbon chain or the number of carbons you have in the chain, and then oxy. For example, if I have OCH3, so I have only one carbon over here, so I will write meth or meth oxy. So basically, this alk represents how many carbons are there in the chain, and then oxy is represented by O. Now, next is halo. Halo means halogens. Halogens are chlorine, bromine, iodine, and fluorine. And their names are, I'll just write it over here, chloro, bromo, fluoro, and iodo. And these names will always be in prefix, irrespective of these are the only functional groups which are present in the chain, or these functional groups are along with other many functional groups. Their name will always be written in prefix. So this is some basic information about how to write a name, though I'm not expecting you to get 100% clarity by now. Though we will learn a lot of rules for naming, and then you will get a better understanding when we'll solve multiple questions. So here I have given you some rules. I have told you what each and every part of the name shows. Even if you have understood 50% of it, rest of the 50% we will be able to understand when we'll start questions. So let's begin the nomenclature. Nomenclature of alkanes, nomenclature of little complex chains, not exactly complex, but the branch chains and the chains which are not just simple carbons attached to it, but have many other things over there. So IUPAC naming today, what we are going to deal with is the complex alkane chains or the branched alkane chains. Till the last class, we knew how to name a normal straight chain alkane. We just have to count the number of carbons. That will give me the word root. We know the bonding structure, that is single bond, and we will put the suffix over there. So that's how we were naming an alkane. But if we have branches in our alkane, then how will we name it? How we will find out what should be the name of the compound. So those rules we'll be discussing today. I'll be giving you examples going forward, and we will have a good practice session, the live practice session, after you watch this video. Okay, so let's start with the first rule. Here we have to follow things according to the rule. You cannot mess out rules. Note down these rules very, very properly. Every single time when you are dealing with the nomenclature, you have to follow rules. You cannot design the names on your own. And there is a way, step by step, how you will be approaching to a name of a compound. Initially, it may look a little lengthier method, but once you will do it twice or thrice, or like you will solve 10, 15 questions, it will just become like this. I mean, you won't have to even think about it. Okay, so keep patience, write the rules properly, follow the rules properly for the beginning, and then after that it will just get into you and you will be able to do it for all the compounds whatever you will get. So the first rule is, as I mentioned, we'll be talking about the branched and complex alkanes, how to deal with them. So what is branched alkane? First of all, you will have to understand that. So when I talk about the carbon chain is straight and has no branch. So basically the required hydrogens have been placed, carbons are linked with just two carbons. This is how your alkane look like. This is your normal straight chain alkane. Now, if I place my carbons like this, see, we know that hydrogens will be there to fulfill the valency, so I'm not bothered about hydrogens. But see, your carbon chain is growing horizontally, and if I write it like this, your carbon chain has grown vertically also. So it's not like a simple straight chain. It has one attachment separately also. Such kind of chains are called as branch chains, which have the separate attachments or branches coming out of it. All of you would have seen branches on the trees, so it's exactly same thing. Now here what we have to do is, the first step when we get any such chain is to find out the longest continuous part. Okay, continuous part means, see, if you are going straight, then the upper branch or the lower branch is a separate part. Okay, or if you are going like this, then it is like, if you're moving like this, then the remaining part is the another part for which you will have to pick your hand and then go to mark it over there. So basically, let me just show you what I'm talking about. I'm not very sure whether I'm making sense or not, but when you're talking about this compound is not the one continuous thing. Either you can say that I'm starting from here and going till here, this is a one continuous chain. Okay, or what you can say is, or you can mark this as another chain, that I am starting from this carbon. I mean, it is completely your choice from which carbon you want to start, but that should be a terminal carbon, cannot be an intermediate carbon. So this is carbon I'm starting with, and I don't want to pick my pen and I want to mark a chain. So this is the chain. This is the chain. Okay, this is the chain. So let me just put it in a box so that you will be able to understand. So this is the chain, right? So here I could go straight, I could go like this. The remaining part for which I have to pick my pen and then go here, that will be acting as a branch. Now, branch can be anything. Can be the part of the straight part, can be the part which is upper, lower. It's completely up to you. So, what is the rule? How will we decide that what I have to consider as a branch, what I have to consider as a main chain, which I'm marking? I have to just look out that in one continuous move, how many maximum carbons I can contain or I can mark, that will be acting as the primary chain for us, or you can also call it principal chain for us, or you can also call it as main chain, anything, any name you can use. So let me just give you an example where approaching from the different ways will give you different number of carbons. I'm not writing hydrogens, please assume that the hydrogens are already fulfilling the valencies. So let's say I have written it as carbon, 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 1, 2, 3, 4, 5, 6, 7. And then, okay, so this is my chain. Just look at this chain very carefully. Now I have multiple ways of marking the chain. I can start moving from here and can go straight. Now I'm done over here. If I have to do anything with respect to this chain, I will have to pick my pen and go here. It's not in the continuous form. It's not continuous. Continuous was till here, till from here till here. How many carbons it contains? It contains 1, 2, 3, 4, 5, 6, 7. So the white color marked chain is chain 1, let's say, or possibility 1, and it contains 7 carbons. Okay. Other thing is, let me take the another chain. Now I don't want to start with this carbon, I want to start with this carbon, assume. Okay, and I will start marking my chain. I will go here, here, here. I'm not picking my pen till now. Another way is like this. So basically I have taken these carbons into the consideration for marking a chain. Now let's count how many carbons are there. 1, 2, 3, 4, 5, 6, 7, 8. So chain 2, 8 carbons. So now let's mark our third carbon chain, and I'm marking this chain with a pink pen. So understand what can be the third possibility of finding the longest continuous chain. I'm starting from here, okay? The pink color one, just see, and going till here, okay? So let me put it in a box. This is my another chain, and let's count how many carbons are there in this chain. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So chain third has 10 carbons in it. So from the same compound, I could find out three continuous chains. One chain was giving me 7 carbons in it, another chain was giving me 8 carbons in it, and the third chain was giving me 10 carbons in it. What will I consider? Which one, which way of marking the principal or primary chain I will consider? The one which is giving me the maximum number of carbons, or which is including the maximum number of carbons. So the third way of marking the compound or marking the main chain is the best way, and basically containing the maximum number of carbons in the primary chain or principal chain. We call it as primary chain, we call it as principal chain, we call it as a main chain, anything you can call it. So this is the right way of marking the main chain, and these two are the wrong ways. So this is our first rule. So what is the first rule? Select the longest chain of carbon atoms in the molecule. How will you do it? I have just now demonstrated you. So I have given this compound CH3, CH2, CH, CH2, CH3, and this blue marked chain is the longest possible chain for this compound. Okay, and how many carbons are there in this longest chain? That we have to count in the next rule. So like, look at the next rule. Next rule is count the number of carbon atoms in that chain and name according to the following rule. So we have not even started naming yet. We have just found out the main chain and the branch. Whatever is there in the main chain or the primary chain is the actual chain, and the remaining portion which is left out will be considered as branch. You can call it as branch, you can call it as substituent group. So this part, let me just show you. So this part, the leftover part of this compound, is called as substituent or branch. Okay, and this is called as principal or primary chain. Okay, so next rule says that we have to count the number of carbon atoms in the principal chain, and next follow the next set of rules to name the compound. So I have checked this in this chain, how many carbons are there? 1, 2, 3, 4, and 5. So total 5 carbons are there in the above selected chain. So here we are done with the two rules. Come to the third rule. When the chain of equal lengths are competing for selection, that chain is selected which has more number of substituent groups. Now let me explain you what does it means. So this is my chain. Okay. Now if I go straight, I'm assuming the hydrogens are already filled. If I go straight and mark chain 1, so this is possibility 1. How many carbons does it contain? 1, sorry. 1, 2, 3, 4, 5, and 6. So chain 1 has 6 carbons. Okay. Now let's mark the another chain, another possibility. That is, I go from here, go here, and contain these carbons inside. So how many carbons are there in it? 1, 2, 3, 4, 5. Chain 2 contains 5 carbon. This is anyways rejected because it has a lesser number of carbons. Let me mark the chain third. So I'll start from here, going, and this is my chain third. Now how many carbons are there? 1, 2, 3, 4, 5, 6. Chain third also contains 6 carbons. So we have two options to consider. One is chain 1 and one is chain 3. Both the ways are giving me same number of carbon atoms. Which one will I choose? Is it up to us? Whichever we want to choose, we can choose. Or we have certain rule here also. So mind it, we have a certain rule over here also. And what is it? Let's see. Let me rewrite the chain again because it is quite clumsy at the, I mean, where I have already written, because I have marked the chains here. One, two, three, four, five, six. And then one, two, and three. Okay. Okay, let me make a small change in this chain. Then it will be easier for us to understand, because the example would be perfect only when I have one more carbon in it. So I've added one more carbon. It's not making any difference in the main chain anyways. Okay. So this is my main. This is one way of marking the chain, and this chain is one straight chain. Will has six carbons in it, and one substituent group over here, one branch or one substituent group over here. So six carbons in main chain and one branch. This is what we are getting from this method. Okay. Now, if I write it again, I've just rewritten the whole thing. Okay. And now I mark the other way of marking the chain. If I follow, I have how many branches in it and how many carbons. So carbons are one, two, three, four, five, six. Six carbons in the main chain. And then how many substituent groups it is basically creating? Let's mark. One substituent group over here, one over here, and one over here. So basically three substituent groups are getting generated, and three branches or three substituents. So chain 3, or this type of marking the chain or finding out the principal chain, is giving me one chain with six carbons, that is maximum number of carbons a chain can contain, and three branches. Whichever chain gives me maximum number of branches in it, that will be my selection. So I will be going by chain 3 rather than going by chain 1. This is what that rule means. When you have two ways or more than two ways of marking the chain and giving you the same number of carbon atoms, you will choose the one which will give you more branches on it. Okay. So let's see the example which I have written over here. I didn't want it to spoil this example because it will spoil the beauty of the compound. That's the reason why I had written it separately, but let's see over here. So I have, so here it is CH3, CH2, CH, CH, CH3, CH, CH2, CH2, CH3, CH2, CH2, CH3, and CH2. So this is very complicated chain, it looks like. Again, you will take this compound and try out different ways to mark the main chain. One way is you can go straight like this. Another way is the way which I have already marked. Other way is you can go like this and like this. Okay, so there are multiple ways you can mark the chain, and let's start. Let's do it. Okay, let's try out on this compound itself. So if I'm marking this chain, this is type 1. I'm getting how many carbons? 1, 2, 3, 4, 5. 5 carbons. And branches, one branch over here and rest is over here. So two branches, two branches. 5 carbons, two branches. This is type 1. Okay. So let me clean it. I don't want this to be messed up. So okay. So type 1 has type 1 has 5 carbons and two branches. If I mark the way it is already marked, I get 1, 2, and 3 branches. And how many carbons? 1, 2, 3, 4, 5, 6, 7. 7 carbons, 3 branches. Okay, so upper one is already rejected. Now another way of selection can be, I can go like this and go like this and can go like this. So total number of carbons 1, 2, 3, 4, 5, 6, 7. 7 carbons, how many branches? 1, 2, and 3. So 3 branches. Okay. So basically these two are same. And then you can have the chain like this. 1, 2, 3, 4, 5, 6, 7. And how many branches? Two branches. So 7 carbons, 2 branches. So here we have 4 options total. 5 carbon, 2 branches, 7 carbon, 3 branches, 7 carbon, 3 branches, and 7 carbon, 2 branches. So 7 carbon, 2 branches rejected, 5 carbon, 2 branches rejected. I have two options, 7 carbon, 3 branches or 7 carbon, 3 branches. You can choose either of them. Now it will not make any difference in the name of the compound. Okay, so here it doesn't matter which one you are choosing, both have the same branches, same number of carbons, so you can choose any of them, and I have already chosen this blue one. Okay, so you could have chosen the other one also, this one also, and it would give you the same name. Okay, so this is how we will mark the carbon chain in the compound when we have different multiple ways and giving the same number of carbon atoms in the main chain. You will have to look for the number of branches. If the branches are also same, then you are free to choose whichever chain you want to mark. Next, till now we have not named the compound yet. We are just trying to find out the primary chain and the branches so that we can name them later on. Come to the next rule, numbering of the parent carbon chain. Now we have got the parent chain or primary chain or principal chain and substituents. Now what we will do, till now we have not named it. Next rule also we are not naming it, we are just numbering the carbons in the primary chain or the principal chain or the parent chain, whatever you want to call it. So I am taking the same example over here. I have started numbering the compound, but what would be the basis for numbering? Basis would be whatever the branches I have, those branches should get the lowest number. Okay, so let's see. So if I'll start numbering from here, from this end, it will be 1, 2, 3, 4, 5, 6, 7. So I have one branch. This is one branch which is on second position. This is another branch which is on third position, and this is another branch which is on the fourth position. So branching, so branch position is 2, 3, and 4. Okay, if I would have numbered my compound from the other end, let's say from here, and if I would have marked 1, 2, 3, 4, 5, 6, and 7, then what would have happened? My one branch would have got 4 as the number, another branch would have got 5 as a number, and the third branch would have got 6 as a number. So here what we do is, because we have the branches, you see the set over here, one set is 2, 3, 4. By one way of numbering, you sum it up, so it will be 5 plus 4, that is 9, and the other set by marking through the other way is 4, 5, 6. You basically sum it up and it is 15, whichever sum is lower, that is what we are going to consider. Or you don't have to even sum it, you can just see and figure out that which is getting the lower positions and which set is getting the higher positions. Higher positions we don't have to consider, lower positions of the branches is something which we have to look for. So we will number it in such a way that our branches will get the lowest positions. So my branches have got second, third, and fourth position by numbering through the given way. Okay, by the given way, we are getting 2, 3, 4. If I would have done it other way around, it would have got 4, 5, 6, which is the wrong method because it is giving me the higher number on the branches. So now numbering is also done. Let's move to the naming of the compound. So let's understand how to name the compound. Now we have got the positions of the branches. We have marked the parent chain or the principal chain. How to name the compound now. So now first I'll teach you how to name the branches, because the normal alkane chain, how to name it, we already know. Let's understand how to name the branch. So for any branch or substituent group, the suffix what we use is alkyl, -il. Let me write it. The suffix what we use is -il, okay, and it will start with word root. Word root will basically tell you how many carbons are present in the branch per branch, not considering all the branches together and counting all the carbons together. Individually in each branch, how many carbons are there, that will decide the word root, and the suffix for the branch will be -il. For example, if I look at our previous example, this is my previous example, and in this previous example, what all I have a branch with 1 carbon, I have a branch with 2 carbons, and then I have a branch with 3 carbons. Please look at it very carefully. I have a branch, one branch containing only 1 carbon, another branch containing 2 carbons, and another branch containing 3 carbons. Now let's move to the naming again. So one branch was CH3, another branch was CH3, CH2, and the third branch was CH3, CH2, CH2. These were the branches in the previous example. So let's start naming them. I told you what is the rule. Rule is word root plus IL. Okay. So here in this branch, I have only one carbon. One carbon word root is meth. So the name will be meth and the suffix will be "-il". So name of this branch is methyl, which was positioned on the second carbon. You would be writing it in your notes. You can see in the compound, it is positioned on the second carbon. So how will we write the complete name of the branch? We will write its position hyphen name. So position is second, where it is placed, then hyphen, and then name of the branch is methyl. Meth because it contains one carbon, "-il" because it is a branch. Come to the next branch. I have CH3, CH2, so I can write it in short as C2H5 totally. Two carbons are there, so word root will be eth. Because it is a branch, the suffix will be "-il" and its position is third, so it will be 3-ethyl. Now next branch has three carbons in it, three carbons, and its position is on the fourth carbon, so 4-propyl. That's how we have individually named the three branches which were present in that compound. Now look at that compound once more. So I have told you this branch is called as methyl. This branch is called as ethyl. This branch is called as propyl. And this is with respect to their position. It is 2-methyl, it is 3-ethyl, and it is 4-propyl. So we know the name of the branches now. We don't have to worry about the name of the branches right now. Next, we have to find out how many carbon atoms are present in the parent chain. So this is my parent chain. 1, 2, 3, 4, 5, 6, 7 carbons. For 7 carbons, the word root is hept. And this parent chain will be named exactly same as the normal alkane. So suffix is going to be "-ane", not "-il". "-il" is the suffix only for branches. The principal chain will follow the regular nomenclature method of an alkane, alkene or alkyne, depending upon what kind of bonding it contains. So it is all single bonds, so it is "-ane". The name will be heptane for my parent chain. I know individual names of branches and the parent chain now. How to write it? Let's understand. So now I know my carbon chain has three branches. One is ethyl, one is methyl, and one is propyl with their positions. And the principal chain has the name heptane. Rule of the naming of a compound is you should write prefixes. We have, I hope we have discussed this already. If we have not, then let's look at it very carefully right now. So the rule is you will write the prefixes name first, or you can say branch name first. Then you will write the word root and then you will write the suffix for the parent chain. So first will come the branch's name, then will come your parent chain name. So we know the branches are ethyl, methyl, and propyl. So these names will come first and then will come your parent chain's name. So we can write it as 3-ethyl, 2-methyl, 4-propyl heptane. All these three names are the branch's name and then comes your parent chain name. Now here look at it carefully. I have put hyphen between the name of branch and the number, and again number and the branch. So basically name and number, name and number have been separated out by using hyphens in between. So you have to use hyphen whenever you are writing name and then after that you are writing a number and then you are writing a name and then you are writing a number. It should always be separated by hyphens. Whereas you don't have to put any hyphen, comma or anything when you are writing the principal chain name. So see, after propyl there is nothing, no comma, no hyphen, and simply we have written the parent chain name, that is heptane. Okay, I hope you would have understood this. If not, try to understand and then we will do lot many questions to get a better understanding of these rules. Now, what is the next rule? Now, in the previous compound, everything we have done, we have found the parent chain, we have found the branches, then we have found the position of the branches, then we have found the name of the branches and the parent chain, and then we have written them together. Now, that cannot be the only type of chain. There can be multiple different type of chains possible. So what if in the previous case, we had three different kind of branches. One was methyl, another was ethyl, third was propyl. If I have two methyls present in the present as a branch in a compound, or two or more than two same type of branches present in the compound, how will we name them? So how will we name them? Let's see. If you have the same substituent occurring more than once in the molecule, then you will use the prefix di, tri, or tetra depending upon the repetitive count of the same substituent. For example, let me just give you an example. If I have a compound containing two methyl groups as the branches, so name of each branch will be methyl. Now I can just show you directly on this example itself. So here I have an example of CH3, CH, CH, CH2, CH3, and then two branches as CH3, CH3 over here. I have already selected my parent chain, which is of 5 carbons. I have already marked the numbering 2 and 3 to give them the smaller number. So my one CH3, one methyl group is present on the second carbon. The name of the CH3 is going to be methyl. Why? Because the word root is meth and the suffix is il. The same is the name for this CH3 also, that is methyl. So I have two methyl groups. One is on second position, one is on the third position. It is very long to write the name as 2-methyl and then 3-methyl, and then writing the name of the compound, which will be pentane, because I have 1, 2, 3, 4, 5 carbons, pentane. Rather than writing so lengthy name, what exactly we do is, rather than writing them repeatedly methyl methyl, we collaboratively write the positions 2 comma 3. So both the positions I have written together, and rather than writing methyl methyl separately, we just write dimethyl. This indicates that there are two methyl groups. One is present on the second position, one is present on the third position. So name has got shrinked a bit. And then we will write the main chain's name, that is pentane. Okay. So similarly, if I had three methyl groups, I would have written three positions together, hyphen, trimethyl, and then the name of the parent chain or the principal chain. So this is how we will name if we have same substituent occurring more than once. Next, let's talk about arrangement of the substituent names. So let me just explain what I'm trying to tell you. Let's say if I have a chain like this. So this is how many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 carbons. Okay, let's make it 10 carbons only. And then I mark this. I mark here like this, and then I mark. Okay, so I have not made it very clean. Let me just rewrite it. I have not written hydrogens because it will just increase the density of the chain. I mean, hydrogens are already there. You have to understand, whenever you are writing, you cannot skip writing hydrogen. I have this choice. Okay. So now I have a chain of 10 carbons with the multiple branches attached to it. Now again, we have to find out the longest possible chain. I have purposely taken the chain this as a longer possible chain so that I don't have to find the longest possible chain. Now I have three branches, one made up of one carbon, another made up of two carbon, another made up of three carbons. So the name of this branch will be methyl, name of this branch will be ethyl, and the name of this branch will be propyl, and name of the compound will be decane, because 10 carbons are there. If I'll talk about the positioning of the branches, it will be 4, 5 and 6. If I'll count from there, it will be 5, 6 and 7. So uh, see, if I'll number from here, 1, 2, 3, 4, 5, 6, 7. So position, my branches will get position 5, 6, 7. If I'm counting from here, it will get 4, 5, 6. So I'll be considering 4, 5, 6. So my methyl is present on the fourth position. My ethyl is present on the fifth position, and my propyl is present on the sixth position. So actually name is 4 methyl for one branch, 5 ethyl for the another branch, and 6 propyl is for the third branch. So we have three branches, and I have the main chain name decane. Now how will I decide which name of branch should come first and which should come later on? Is it a random sequence? Can we write it randomly, or do we have to follow a specific rule? Mind it, we have to follow a specific rule while writing the name of substituents also. Substituents are always written in the alphabetical order. So look at the first alphabet. It is M here, it is E here, and P here. Which comes alphabetically first? E comes alphabetically first. So I'll be writing 5 ethyl. Then comes your M, so 4-methyl. Then comes your P, so 6-propyl. I had to put hyphens over here. Okay, and then comes your decane. That's how we will name it. So it will be always alphabetical order which you'll be following when you are arranging the substituent's name also. But one thing, what you have to keep in mind is if there are repetitive substituents anywhere, like as I mentioned, that 2-methyls are repeating and you are writing dimethyl. If let's say you have to compare the positioning of, or you have to figure out whether dimethyl should come first or ethyl should come first, this is very important. Understand this. Di, that means prefix di, tri, tetra will not be considered for the alphabetical order. The actual name of the branch will be. So basically, though D comes first and E comes later on in the alphabetical order, we are not considering di for the alphabetical arrangement. We will be checking the methyls M and ethyls E for the alphabetical placement in the naming of a compound. So in this example, if you see, we have three branches, CH3, C2H5 and CH3. This CH3's name is methyl. Another CH3 name is also methyl, and the other branch name is ethyl. Okay, so three branches, two methyls, one ethyl. Let's look at the positioning of it. 1, 2, 3, 4, 5, and 6. So two methyl groups are present on the second position and the fourth position, and my ethyl group is present on the third position, right? So we know the positions also. So I can write methyl as 2, 4 dimethyl, and ethyl will be 3-ethyl. Correct. Now the main chain has 6 carbons. The name of the main chain will be hexane. How to arrange these names together now? We have ethyl and dimethyl. Now we have to write the names of these branches first and then name of the hexane. Deciding whether dimethyl will come first in the name or 3-ethyl, we have to look out for the alphabetical order. And as I have mentioned just now, di is not considered for calculating the alphabetical order. Methyl is, or M is. So methyl ka M comes later and ethyl's E come first. So the name will be 3-ethyl 2,4 dimethyl hexane, because out of E and M, E comes first. Di will not be considered. In fact, any prefix di, tri, tetra will not be considered for the alphabetical order naming. Okay, this is about how to name the complex alkanes. All these rules you have to club up together while thinking about the naming of a compound. And there are some important things which you have to take care of. What are these important things? Numbers should be separated from each other by comma, as I have separated it over here. When I'm writing two numbers together, I'm separating them by comma. If you are writing numbers and words, there should be hyphen in between. So it should be 2, 4 hyphen dimethyl. Look at it. So there is a hyphen between number and name and number. There are always hyphens present. So you have to place the hyphens. Write the name of a compound in single word. When you're writing the compound name, this should not have any space in between. So this should be, I mean, I have written a small space to just show you. I think this is dimethylhexane is one whole thing. There should not be spaces in between. Everything should be written together. When you are writing it on the computer, that will actually show you whether there is space or not. For example, if I'm writing 3 hyphen ethyl hyphen means there is no space in between, but just hyphen is placed, comma dimethyl. uh, Let me write it somewhere else. So it will be like this: 3 ethyl hyphen 2 4 dimethyl hexane, no space in between. These are some important rules which you have to follow while naming the compound. I hope you have understood the rules. If you have not, go through the video again, try to grasp the information given, try to write them at one place, and then try to make the link between these rules. Okay, and now try solving these 4 questions. Try out these questions. This is question number 1. Try this out. Then comes your second question. Try this out. Then comes your third question. And now comes the next question. So try out these four questions, and we will discuss the name of these compounds in the next class, that is on the weekend. Try out these questions on your own using the rules, and I'll be sharing the answers with you on the weekend, as well as we'll do many more questions of the similar kind in the next class. So now I have explained you the nomenclature rules, the basic rules what are required to name a chain, how to name a branch, how to number a branch, how to find out the longest possible chain, how to find out the principal chain, and how to collectively write all the names. And we have seen multiple examples also. Here I had missed out on one type of compound or one type of alkane chain where you have complex chains, or you can say branch within branches. Okay, let's not go by the name, let's understand what exactly it is. Okay, so let's say we have seen what are alkyl groups and what are branches. So I have, let's say I want to draw a branch. If I talk about the branch made up of 3 carbons, what all different possibilities are there? The branch which is an alkane branch, all the single bonds, the branch can be CH3 CH2 CH2. If such branch will be there on any carbon chain, let me draw a carbon chain. So if I want to, this is my chain, let's suppose, and this is my principal chain also. This is my principal chain, okay? And I have a branch. I'm saying that there is a branch of 3 carbons. What all different possibilities are there? One possibility is that my branch is CH2, CH2, CH3. If this is my branch, what is going to be the name for this branch? The name of this branch is going to be propyl. Why? Because there are 3 carbons over here. So word root is prop, and for branches, we know what is the suffix. Suffix is il. So this is propyl. But these 3 carbons could have been arranged in a different manner also. And what is that manner? Instead of the 3 carbons being arranged like this, if the chain would have been in a little different manner, let me show you how. If the chain would have been this way, this branch still have 3 carbons, but what can we see over here? Branch, this is my carbon. Okay, all 3 carbons are not in one chain, are not in the straight chain. Instead, there is a branch and then there is a further branch. So there is a vertical growth, sorry, there is a horizontal growth and there is a vertical growth. Both type of growths are there, and we cannot say that this chain is same as propyl. So what exactly is the name going to be for this branch? Mind it one thing very, very carefully. For such branches where in the branch itself you see one more branch or further branches, we have to follow the exact rules or sequence of numbering, naming, and finding out the longest possible chain as we do for the main principal chain. Here also, this is the main chain 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have written the name, no name. So I am done with this. Now I have to write the name of this branch. How will I write the name of this branch? I will again follow the same set of rules. I'll try to find out the longest possible chain in the branch also. So, longest possible chain can be vertical, can be horizontal, because both ways you are going to get the same chain. Let's say I mark this chain as the main chain. Then this is the branch for it. Please understand it carefully, very, very carefully. This is my main chain of the branch, and this is the further branch to it. And along with that, we also have to number the carbons of this branch. The carbon which is directly attached to the principal chain, that will always and always and always be numbered as the first carbon. So this carbon is the one which is directly attached to the main chain. Hence the number which will be given to this carbon will be 1 always. Now depending upon which way I'm choosing my main chain, or you can say which is the chosen chain in the branch, this is the chosen chain, I'll mark it 2. Okay, so my main chain of the branch contains 2 carbons, so this part of my chain will be named as ethyl. Now how will I name this further chain? This further chain is made up of only 1 carbon. This is methyl. This is the branch of a branch. Where exactly it is located on my branch? It is located on the first carbon. I had marked this carbon first, right? This carbon was marked as first carbon. This methyl group is present on the first carbon. So I will mark it as 1-methyl. So how will I write it? I will write it as 1-methyl, which will represent the methyl is a branch which is present on the first carbon of what? Of my branch named as ethyl. So on ethyl, there is a methyl which is present on the first carbon. This is how the whole branch will be named. The main branch, ethyl is the name. The branch on that branch is methyl and it is present on the first position. So name will be 1-methyl ethyl. So I have mentioned it over here. There is a common name for such branches and the common name is isopropyl. What does the iso means? Iso means when the CH3 as a branch is present on the carbon which is directly attached to the principal chain. Which is directly attached to the principal chain. Such kind of combinations are called as iso groups or such for such compounds we use the term iso. Iso means when a branch CH3 is on the carbon of the branch which is directly attached to the principal chain. Now, let's talk about the another case. If I have to take a branch which is made up of 4 carbons, what all different possibilities there are there? One is the straight chain, we will call it as butyl, or we can also call it as N-butyl. N-butyl represents that there is no branching in the branch. It is a normal branch, normal butyl group. But there are other ways also these 4 carbons can be arranged as a branch. One way is this is CH3, CH, CH2, CH3. This is how it is attached to my principal chain. This is my principal chain, let's suppose. Okay, or main chain. So in that case, how will I name this branch? Again, as I mentioned, find out the longest possible chain. This is my longest possible chain of my branch. Let's start numbering. Numbering will start as 1 from the carbon, which is directly attached to the principal chain. So this is 1, this is 2, this is 3. The CH3 is acting as a branch. Let's name this part first. The name of this part is propyl. Name of this CH3 is methyl. Where exactly this methyl is present? On the second carbon. So the name will be 2-methyl propyl. This is going to be the name of my branch. If I have to write it in the common name will be isobutyl. So here in this case, where are we using iso? Iso means a CH3 as a branch is present on the second carbon. In the previous case, the CH3 was attached on the carbon which is directly attached to the principal chain. Here the CH3 is attached on the second carbon. These are some common names which doesn't make much logic, which are not being followed through a logic. That is why the IUPAC name is there, which basically follows certain rules and logics and you can directly apply it. Here you will have to remember these names, the common names. This kind of structure where CH3 as a branch is present on the second carbon for the 4-membered branch will be called as isobutyl, which is in short can also be written as isobu. Now, let's see what other way we can have this branch. We can write this branch in other way as CH3, CH2, CH, CH3, and then it can be attached to the principal carbon chain, right? Now, what is the difference between previous case and this case? In previous case, the CH3 was present on the second carbon, whereas here, right now, the CH3 is present on the first carbon. This is my principal chain of my branch. I will mark this as a carbon 1, 2, and 3. How will be the IUPAC name of this compound? The IUPAC name of this branch will be 1-methyl propyl. Very easy to understand and much more logical than the common name. What will be the common name of this compound? Common name will be secondary butyl. This CH3 is present on a secondary carbon. Why secondary carbon? One carbon is present over here, one carbon chain is here, and this CH3 is being considered separately, and we will call it as secondary butyl. These names you will have to remember, so you have no choice. Okay, and we also write it as sec-bu. You should know to differentiate between secondary butyl and isobutyl. It can be confusing certain times. Isobutyl is when CH3 is present on the second carbon. Secondary butyl is when CH3 is present on the first carbon of a branch. Now come to the next way. Other way how four carbons can be arranged is carbon with CH3, CH3 and CH3. Basically, you have arranged it in this way. Now there is the center carbon over here. If you write this chain, it will be CH3, CH3, CH3 with the principal chain. Now if you want to mark the main chain can be this. Now you mark the carbons. This is one carbon, this is two carbons. So on first carbon, there are two branches, that is 2CH3. So you will write 1 comma 1 dimethyl ethyl. This is the way of naming of a branch in this case. Basically, IUPAC naming. What is the common name going to be? Common name is going to be tert butyl for such group. Very important name, very, very important name. When they give you an exam, they give you these names, common names. When you have to write an exam, you have to write IUPAC name. You are nobody to choose these common names. You will just not write these names because the CBSE or PU will not accept it. And in competitive exams, you don't have any choice. I mean, they won't give you a choice to write any answer. It will be just their question and you will have to write, or you will have to understand or comprehend the compound. Okay, so this is your tert butyl, is also written as tert bu. These are some very important terms and very important ways of writing the names. Okay, writing the names of the branches which can be made up of same number of carbons but in multiple different ways. Okay, this is very, very important. So now let's see the application of these things what we have learned just now. Let's say I have this chain. I have taken this chain which is made up of 10 carbons and I have placed multiple different branches over here. One branch I have put here as CH3, another branch I have put as C2H5, third branch I have put is this. Now, first of all, what we will do is we will find out the longest possible chain. So this is my longest possible chain which has 10 carbons. Okay, so the name of 10 carbon chain is decane. Now we have to start naming the branches. So one CH3 will be named as methyl, C2H5 will be named as ethyl, and now this is the complex branch. So here we will try to find out the longest possible chain. This is my longest possible chain. Let's number it. Numbering will be 1 here, 2 here, and 3 here. So you have CH3 on the first carbon. So name of this compound will be, or name of this branch will be 1-methyl propyl. I have shown you just now that why this name is 1-methyl propyl. I mean, we have just now done it. So you simply can ignore writing 1 and you can simply write methyl propyl also. Unless it is on some other position, you need not to specifically mention position 1. Okay. Now, where these branches are present according to the chain, on the second carbon, your methyl is present. On the third carbon, your ethyl is present. On the fifth carbon, this complex branch is present. So we will write it as 2-methyl, 3-ethyl, and 5-methyl propyl. Now what we have to do is we have to arrange them in the alphabetical order and place it in the prefixes along with the principal carbon chain. So let's see whether we have arranged them in the alphabetical order or not. So here when we are considering the alphabetical order, we have E for ethyl, M for methyl, and P for propyl. So we are ignoring this methyl for the naming or alphabetical order. Okay, so out of EMP, ethyl comes first, then comes methyl, then comes propyl. So 3-ethyl, 2-methyl, 5 bracket. It is mandatory to write the bracket 1-methyl propyl decane. That's how we will name these complex chains. I'll give you many more questions to solve. We will solve some questions in the next class after doing the alkenes and alkynes naming also. Along with that, you will get a worksheet where you will solve these questions, practice more and more, and you will get thorough with it. It's not a big deal to know the namings of alkanes, alkenes, and alkynes. When the functional groups will start, the complexity will actually start over there. These are simple chains. You should get it in one go. So here is the thing. Ask me if you have any doubt in the doubt session. Till here, if you have any doubt, you can ask me in the doubt session. And next class, we'll talk about the naming of alkenes, alkynes, and many more questions we'll practice for the namings of alkenes, alkanes, and alkynes with the branches, multiple different unsaturated structures where you have multiple double bonds, multiple triple bonds, and then we will talk about the cyclic chains also.